Hello, Algebra 2. Here's semester exam review, module 2. We are on to absolute value functions. So you have your calculators with you, so by all means plug these guys into your calculator, help with your graphing. But the quote-unquote vertex of this absolute value is going to be at the opposite of this guy. Think of these as your parentheses, kind of. Opposite of this guy, same for this guy. So it's getting shifted to the right 3 and up 4. So that's going to be where my vertex is starting. The middle point of my V for my absolute value. And then it's negative, so it's opening down and it's not getting vertically stretched. So it's going to go down 1 over 1, down 1 over 1. Put a couple of points. Kind of guide me, something kind of like that. And then down 1 over 1, down 1 over 1, down 1 over 1. Like so. Domain for absolute values are all real numbers. You might see it written like this. All right, and our range, it's going down to negative infinity, so that's where we're going to start. The highest point here is up at 4, so it's going to end at 4, including 4. For number 2, notice we didn't shift it to the left or the right, but we are shifting it down to 5, negative 5. And this time we're opening up, but we're opening it up by a factor of 2. So for every one I go over, it's going to go up 2. Look kind of like this. Domain again is negative infinity to positive infinity. Range this time we've got a minimum point, so we're going to go down to negative 5, that's where it starts, and then your y values go on and up forever to infinity. Number 3, my quote-unquote vertex is at negative 1, positive 3. I'm going to go to the left 1, up 3. And there's my point at negative 1, 3. We're opening down, this time at a rate of 1 over 2. So I'm going to go down 1 over 2, down 1 over 2. Like so. And same thing on the other side, down 1 over 2, down 1 over 2, down 1 over 2. And so my domain is negative infinity to positive infinity. My range, though, I'm starting at negative infinity because it's opening down. I'm just going up to 3, including 3. All right, this one's a little harder. This one is the absolute value of negative x plus 2. Well, that plus 2 is actually going to shift us to the left 2. So we're going to start here. And then this is a flip across the y-axis. So what it's really doing is we're taking this graph that looks like this. We're flipping this leg with this leg, but for an absolute value, it's going to end up in the same spot. And then we're shifting it to the right 2. So this is what it would end up looking like, roughly. Again, our domain is negative infinity to positive infinity. Our range is from 0, this time to infinity. All right. For number 5, our vertex here is kind of at 3, 1. I'm going to go over 3, up 1. There's the vertex. And now we are inside. This is going to be a horizontal stretch. So we're going to go up. We're going to do the opposite of what it says. It says to go up 1 over 2. Instead, we're going to flip that number upside down. We're going to go up 2 and over 1. So up 2 over 1, both sides. And as I said, when you get to these guys, feel free to graph them on your calculator. It's not this hard on your test, but don't tell me when I said that. All right, so negative infinity to positive infinity for the domain. Your range starts at 1 and goes to positive infinity. Now we're going to get to solving some absolute value equations. You will have some of these on your test. This one says to solve the absolute value equation by graphing. So first we're going to do this side, and then we're going to graph this side. So this is an absolute value that's centered at negative 5, negative 3. So negative 5, negative 3 is here. No vertical stretch or compression, so it's just going up 1 over 1, up 1 over 1, up 1 over 1. And then my other line is at negative 1. We want to know, where do these two guys intersect? And so 1 is at x is equal to -7, and the other one is at x is equal to -3. All right, same thing for number 2. This graph is centered at 1, +3, but we're going opening up, and it's going up by a factor of 2. So we're going up 2/1, up 2/1, like this. All right, try to hit that a little better. And then the other line is at 5. Y is equal to 5 is right here. My 2 intersection points for these guys are here and here. So that's x equals 0 and x equals 2. That would be your 2 solutions. And let's try to do number 8, and then we'll move on to the next video. All right, for number 8, same thing. Graph centered at +2, +3 would be right here. We're opening down at a rate of 1 to 4. So we're going to go down 1 over 4, down 1 over 4, down 1 over 4, down 1 over 4, like so. And we want to know, when does this guy equal 1? All right, so this one's a little harder because it's not, hitting at one of these points, but I think we can all agree that it's going to be right here at 7 and at -6. How can I check to make sure it's right, even if I've got it in the calculator? If I've got it in the calculator, I'm going to find the intersection point between those two graphs. But I can also check, sorry, let me write this down first. Sorry, that's at x equals 7 and x equals -6. I can check these by plugging them back in and making sure it makes a true statement. So 7 minus 2 is 5. Absolute value is 5 minus 1/4. Oh, it's not quite at those points. Again, if you have a calculator, which is what we're going to need for this, because this one is not at a precise point. If you have a calculator, you're going to graph your x graph. So you're going to graph this guy first, and then graph this guy. And so then on your calculator, you're going to analyze your graph, and you're going to get that dashed line. You're going to put it on one side and on the other side, and it'll pop up that intersection point for you. This one is kind of hard to solve by graphing, not the best one to do by graphing. So if you saw it on your test, I would definitely use a calculator for it. If you have questions about what I'm saying, please come, and trust me when I say it's not going to be this challenging on your final.